So now let's continue the earlier problem. Now we want to calculate d1 and d2, and we have developed the equation, matrix equation. After this inverse we have calculated, then directly now you will get d1 is equal to 1 upon 7 EI. Now this is 2 into 8 minus 1 into 12. So you will get d1. Then d2 is equal to 1 upon 7 EI into bracket. This is minus 1 into 8, and this is 4 into 12. So equal to this you will get in terms of EI. So now you find out this, you do the calculations for this. Now after getting d1 and d2, say next step is to find out end moments. Now end moments, final end moments. Say here MAB, what we have to calculate is this moment. MAB, then this MBA, etc. So this MAB this is anti-clockwise. So just summation of this is MAB. But remember, this coefficient is to be multiplied by D1 and this coefficient is to be multiplied by D2. But here there is no coefficient, only this minus 20 plus EI by 2 into D1. So MAB equal to minus 20 plus EI upon 2 D1. So you calculate this. Then MBA equal to, MBA means on the left of this support. So this 20 clockwise, this is clockwise, and there is no coefficient here, that is, this is EI, remember this 4 gets cancelled. So 20 plus EI into D1 equal to, you find out MBA. Then MBC is equal to, MBC is equal to this minus 24 plus EI D1 and plus EI by 2 D2 is equal to, and remember MBA and MBC must be equal and opposite. If this is positive, this must be negative, equal and opposite. And MBC, MCB must be equal to, MCB is, say, this 24, then EI by 2, D1 and plus EI D2. This you will get 30 kilonewton meter. And the MCD, that way that we know, minus 30 kilonewton meter. Now with these values, knowing these end moments, we can draw BMD. If you want to draw shear force diagram also, find out the reactions and construct SFD also. Now a few more problems we will see. So solve more number of problems so that you can understand the method in depth. If you want to understand stiffness method in depth, so try to solve the more and more number of problems. Say the next part is the element approach, but that is not in our syllabus. So next, let's consider one problem of frame. Suppose we have, say I am taking support hinge here, then say loading horizontal load 10 kilonewton, and take here 12 kilonewton per meter, 5 4 meter and say this is 5 meter, A, B, C. Say support at C is hinge. So what are the unknowns? Theta B and theta C. So what type of this frame? Remember, this is non-sway. Because at C there is a hinge. If roller is there, then it would have been a C sway type frame. If this is the case, what are the unknowns? So unknowns you can write here. That is theta B, theta C. Let theta B equal to D1, theta C equal to D2. Assign the coordinates. Means we will assign the coordinates like this. Say this is fixed and here there is a hinge. So let's take clockwise rotations. Say this is D1 and this is D2. So D1 and D2 we have assigned the coordinates. Now next, so make it fix, restrain the structure. Say obtain a restrained structure. Say make it fixed. This rigid joint, so make it here fixed. Do not allow any rotation. So this is a restrained structure and show the external loading acting on it. So this is the only load, external load on the member. Member loading only you show 12 kilonewton per meter. Because 10 kilonewton is a horizontal load, that is joint load. So find out this end fixed end moments. So WL square by 12. So we know this is 60 and this is 60. So because rotations are only unknown, so no reaction is required. So only end moments are required. So in the direction of first, so this is nothing but AD1L. Or we can see, we will do like this. So you write here AD1L equal to this minus 60 because anti-clockwise, and AD2L, so this is plus 60 clockwise. Now and what is AD1 original action is 0, AD2 original action is 0, no original actions. Now next, stiffness, let's find out stiffness coefficients. How to find out stiffness coefficients? Now here allow rotation, only rotation without any translation, clockwise. If you rotate this joint clockwise, so you will get the rotation like this, you will get a rotation like this. So means after deformed shape, if you draw the tangents to the elastic curve, the angle between the tangents should be 90. Now this, draw a tangent here, draw a tangent here. This rotation is 1, this rotation is 1, that is clockwise. So clockwise rotations at the joint for both the members. So what will happen? So because of this clockwise rotations, the clockwise moments gets developed. And due to rotation we know clockwise here, this is 4 EI upon 4. So that means this is EI. And here half of that, EI by 2. Similarly, here clockwise moment, so this is also clockwise, and this is again 4 EI by 5. This is 4 EI by 5. And half of that clockwise, so half means this becomes 2 EI by 5. 2 EI by 5, right? So now, okay, only we are interested in end moments. So this is in the, both are clockwise in the direction of first due to first. K11, so this is EI plus 4 EI upon 5. This is 4 EI by 5. So this will be 9 EI by 5. Then K21, this actually gives us the first column of the element stiffness matrix. this EI by 2, that's all, and clockwise. So these are to be multiplied by D1 while writing down final equilibrium equations. Now next, let's consider the next displacement in the direction of second coordinate D2. So keep this as fixed, allow rotation here, that is clockwise rotation. So this is clockwise rotation. Now what is the moment developed here is clockwise. That is 4 EI upon L is 4. So this is only EI. And then clockwise here, half of that EI upon 2. So that means in the direction of 1 due to 2, EI by 2. So K1, 2 and K21 must be equal. Then in the direction of 2 due to 2, this is EI. And these are to be multiplied by D2. These are to be multiplied by D2. Then say, almost our problem is over. Almost problem is over. What is next? Next you just develop equations. Say A D1L plus K11 D1 plus K12 D2 equal to no original action, therefore 0. Then A D2L plus K21 D1 plus K22 D2 is equal to 0. So substitute the values and you find out the, or say we will try this problem. Okay, anyway, calculations are simple. AD1 L is minus 16 plus K11 is 9 EI by 5 D1 plus K12 is EI by 2 D2 equal to 0. Say this will be now 9D1 equation plus we can write down 1.8 D1 plus 0.5 D2 equal to 16 upon EI. So first equation, 9 divided by 5. Then second equation, A D2L plus K21 D1 plus K22 D2 equal to 0. So this is 16 now, plus 16. K21 is EI by 2 D1, K22 is EI D2 equal to 0. So just this is 0.5 D1 plus D2 equal to minus 16 upon EI, equation 2. So let's solve these two equations. I think this is very simple. So you will get matrix 1.8, 0.5, 0.51, then D1, D2 equal to 1 upon EI and vector 16 minus 16. So solve this and find out D1, D2. So after getting D1 and D2, what are the end moments? Our interest is to calculate end moment. So you solve this. Then MAB is equal to MAB. So there is no fixed end due to loading, no moment here. This is clockwise, 2 EI upon 5 T1 and D2. So there is no moment, that's all. This is your MAB. MBA is equal to, again, this clockwise 4 EI by 5 D1, and here, okay, this is MBA. Then MBC equal to this minus 16, then plus EI D1, and then plus EI by 2 D2. So these two you will get equivalent opposite. These two you will get equal, and CB is 0. That's all. So this 10 kilonewton load, when we calculate horizontal reaction at C, then only that load will come into picture. Okay. So you complete the calculations and then find out the end moments and draw only BMD. Draw BMD. So I expect here from you to complete the problem up to the BMD. You solve these problems at home. So now I will solve the remaining problems partially, and I hope you will complete this at home. Now what I will change, let's take the same problem, but instead of hinge, let's take a roller support here. Let's take roller support. So what will happen? There will be one more additional unknown. This is a sway type frame. This is sway type. That means what are the unknowns now located? Unknowns, theta B is there, theta C is there, and horizontal, that is sway of the frame, delta will be there. So let's put, let theta B equal to D1, theta C equal to D2, and this delta is equal to D3. That is horizontal. If you want horizontal means delta H, you can write down. Horizontal sway, horizontal deflection. So let it be D3. Now assign the coordinates. Assign the coordinates. Now coordinates are assigned in the direction of unknown. So this is as usual. Previous we have seen this D1. This is D2, and horizontal you take at beam level anywhere D3. So you take at D3. Now next, let's find out fixed end actions. Restrain the frame. So make it restrain. And just now we have calculated. So this is anti-clockwise 60 and this is clockwise 60. Now for vertical column reactions are required, but there is no load on vertical column. Now one more thing is that what are the original actions? So this AD1 0, AD2 0, there is no concentrated moment acting at B and C, and AD3 is equal to 10 and positive because towards right, and D3 is also towards right. So AD3 original actions, this is 0, but this is equal to 10. Now here fixed end moments WL square by 12. So now let's find out AD1L minus 16, AD2L plus 16, AD3L 0. There is no horizontal reaction for column, vertical column. Now in the next case, let's apply, say keep it fixed, this is fixed, and rotation here, say the rotation applied here is 1, here is clockwise is 1. Now because of this rotation, so this is clockwise moment developed here is 4 EI by L, and 4 gets cancelled, this is EI and this is EI by 2. And for this member, vertical member, clockwise this end, this is 4 EI by L, L is 5, half of that clockwise 2EI by 5. Now the vertical member column is now subjected to end moments, and therefore column will subjected to horizontal reaction because we have D3 horizontal sway as a unknown. So the reactions in the direction of D3 are required to be calculated. So this produces clockwise, and due to this anti-clockwise. Reaction at column end you can show like this. Reactions at column end. Sum of column end moments divided by height of column. So 4EI by 5 plus 2EI by 5, this plus this, 4EI by 5 plus 2EI by 5. So 6EI by 5 divided by 5. So 6EI by 25. So this is 6EI upon 25. Now we can write down the coefficients K11 equal to this plus this, that is EI plus 4EI by 5 equal to 9EI upon 5. Then K21 in the direction of 2 due to 1. 2 is EI by 2 only, this value, and K31 is equal to this value in the direction of D3. But D3 is towards right, this is towards left, so minus 6 EI upon 25. And all these are to be multiplied by D1. These are to be multiplied by D1. So now the next is, say, apply, say keep it fixed, do rotation here clockwise, say this is 1. So that means here 4 EI by 4, so only EI. And further end, this is EI by 2. Okay. Now, that's all. There is no load on column, so no end reaction for column. Now directly let's write down in the direction of 1 due to 2, EI by 2. In the direction of 2 due to 2 is EI. And in the direction of 3 due to 2 is 0. So there is no horizontal reaction. So this is to be multiplied by D2. And the last, let's give unit deformation in the direction of D3 now. So this we are going to keep this as fixed, no doubt, remember. So here the horizontal sway is to be given. And this horizontal sway, see this is fixed, remember. So we have given the sway only, and this is 1 unit. This is again, when we assume the sway of the column towards right, we know the column ends developed are anti-clockwise, and here it is anti-clockwise. And both are 6 EI delta upon L square, delta is 1, L square is 25. So this is 6 EI 25 and 6 EI divided by 25. Now the column, horizontal reaction for column will occur. This total is anti-clockwise. The reaction should form clockwise couple. So reactions for the columns. Now what are these reactions? This total moment divided by span means this 12 EI divided by 25 into 5. So total divided by span means 125. This is 12 EI divided by 125. 12 EI divided by 125. Now let's write down the coefficients, stiffness coefficients. So this in the direction of 1 due to 3, K13, this is minus 6 EI upon 25. 6 EI upon 25, this value. And here there is no any rotation, K23 is 0 and K33 is this value, that is, and positive 12 EI upon 125, and all these are to be multiplied by D3. Say we have prepared, now there are three unknowns, means three equations will be developed. Three unknowns means three equations will be developed. What are those three equations? So by using equilibrium conditions, so AD1L plus K11D1 plus K13D3 equal to AD1. So first equation you develop. Then AD2L plus K21D1 plus K22D2 plus one term is left here. So I'll write down once again. AD1L plus K11D1 plus K12D2 plus K13D3 equal to AD1. First equation. Then AD2L plus K21D1 K22D2 plus K23D3 equal to AD2, second equation. And then the third, AD3L plus K31D1 plus K32D2 plus K33D3 equal to AD3. This is third equation. So develop these three equations because everything has been calculated. Solve them. Solve these three simultaneous equations. What you will get? D1, D2 and D3. The unknowns you will get theta B, theta C and delta. And then by using slope deflection equations, you can find out MAB, MBA, MBC just like a previous problem. And then you construct bending moment diagram. So you complete this problem up to the BMD. Now that means you must be able to solve the problems on continuous beams, then fixed beams, propped cantilevers, portal frames, simple frames, etc. Each and every type of problem you can solve by using this. Say I'm giving this, I think we have solved earlier, so let's you complete this at home as an assignment. Say you take this as 12 kilonewton meter, say this is 3 meter and this is say 3 meter, and you solve this problem. A, B. Say what I want is RB. Let's find out reaction at prop. So you do this, you solve this at home. Then one more problem, let's try, which we have solved earlier. So I am taking here hinge and applying a 40 kilonewton meter concentrated moment. Say this is 3 meter, this is 4 meter, A, B and C. See, we have solved this problem earlier by using flexibility method. You check the answers of this problem by solving using stiffness method. So solve by using stiffness method and just verify the answers. So here what here you solve this only theta B. You take this as unknown. Taking theta B as unknown, you complete this problem. Okay. Then here say what are the unknowns? Say theta B equal to D1 and theta C equal to D2 be the unknowns. Then here it is very clear that AD1 is 0, AD2 is minus 40, is 40.